Students, in this video I will explain about water system. Water system is a one component system. Although water exists in three states, that is solid, ice or liquid water or the water vapor state, it is always represented or expressed as a H2O only. The chemical formula for water is always H2O only, whatever state it exists in. So it is a one component system. So if you see the phase diagram for water system, it is a graph plotted between pressure and temperature. It consists of three curves, OA, OB and then OC. OA is called as vapor pressure curve because it lies between the water and then the water vapor. And then OB is a sublimation curve because it lies between solid ice and then the vapor. Solid to vapor is a sublimation process, right? So, and then OC is a melting curve which lies between solid ice and then the water. So, solid to water is a melting process. So, this curve is called as melting curve. And there are three areas. Okay. So, the area under AOC consists of only one phase, that is water. An area under AOB consists of only one phase, that is water vapor. An area under BOC consists of only the ice, that is solid state. Now let us calculate the degrees of freedom. So the formula is F is equal to C minus P plus 2. This is the phase rule. F is the degrees of freedom, C is the component, P is the number of phase. So F is equal to C minus P plus 2. So let us calculate the degrees of freedom under the area. So under the area, only one phase exists, either water or water vapor or the solid ice, isn't it? So only one phase. So if you substitute the number of components, C is equal to 1 and P is equal to 1. So F is equal to C minus P plus 2. So F is equal to 1 minus 1 plus 2. So F is equal to 2. So under every area, degrees of freedom will be equal to 2. Okay, and then along the curve, so along the curve, two phases exist. So for example, if you take AO curve, which is a vapor pressure curve, two phases, water and then the water vapor exists. So similarly, BO curve, in that the solid ice and then the water vapor exist in equilibrium. If you take the curve was CO, the water and then the solid ice exist in equilibrium. So along the curve, two phases are there. So F is equal to 1 minus 2 plus 2. So F is equal to 1. So F is equal to 1 along the curves and F is equal to 2 under the areas. Now let us calculate what is F is equal to at the triple point. So what is the triple point? Where all the three phases exist in equilibrium. So all the three curves are getting connected here, and three phase, that is solid ice, water and water vapor, everything is in equilibrium at this phase. So three phase, P is equal to 3. So F is equal to 1 minus 3 plus 2, you get F is equal to 0. Okay, F is equal to 0 at this point. So this point is called as triple point. So at this point, pressure and then the temperature is fixed. So pressure is 4.58 mm and then the temperature is 0.0075 degree Celsius. So no variable at this point, everything is fixed. So F is equal to 0. Below minus 273 degrees Celsius, the system exists as ice. And above 374 degrees Celsius, the system exists as vapor, or the system exists in vapor state only. Also there is metastable equilibrium. So this equilibrium is between supercooled liquid and then the ice. So what is supercooled liquid means? Its temperature is below 0 degrees Celsius, but still it exists in the liquid form. So under small disturbances, it gets converted to solid ice form. So that state which is whose temperature is below 0 degrees Celsius but still exists as water is said to be supercooled liquid. So the equilibrium existing between supercooled liquid and then the solid is said to be the metastable equilibrium. Even under here the degrees of freedom F is equal to 2.